All right, guys, in this video, we are going to complete the 4.3 section. It's just where they're going to start touching on the idea of what a periodic function is and what the periods of sine, cosine, and tangent are. So a periodic function is a function that repeats itself. So all the outputs will repeat itself after a given amount of time. That amount of time, or the amount of, the period of time where it takes to repeat, is called the period of the function. So I know that the wording on this definition is kind of complicated, but essentially what a periodic function does is it just repeats itself after so much time, and it's like even intervals. Okay. So when I look at my unit circle, here's one way that I can kind of explain what this really is meaning. I'm going to pull my unit circle back, and I want you to think about what sine and cosine are. So sine is your y, cosine is your x. If I was looking at, let's say, sine of 30 degrees, right? 30 degrees sine is 1/2. Now, what about if I did 390 degrees? Well, 390 degrees is a whole extra revolution, but it's coterminal to 30 degrees. It lands in the exact same place. So because it lands in the exact same place on the unit circle, the sine value is exactly the same. It's 1/2. Right? If I went around another revolution, again, it will be a different angle, but the sine value will be the same. Every time you go around the circle, 360 degrees or 2 pi radians, the sine value repeats. And the exact same thing with cosine. Now you will see that in other scenarios, like see, sine is 1/2 here, and then on the other side of this guy, it's 1/2 again, but it's never positive 1/2 again, and this is not even intervals. So if you looked at this, it's not like, like what is that? 120 degree is how long it took to start repeating. It's not going to be consistent. So if it took 120 degrees to repeat, you would think if the period was 120 degrees, that it would repeat again in 120 degrees, but it does not. Okay. So the period is like the even intervals for where it starts. It's going to repeat over and over and over and over and over and over. Every single 2 pi radians, it's going to repeat. That's why you're seeing the period of sine and cosine to be 2 pi, because both of those, they repeat every single 2 pi. So even values of pi. Now, tangent is a little bit different. It's a little nicer because it repeats every single pi. Every half of a revolution, it repeats. So whether it is an even or an odd value, it's going to repeat as long as it's whole values of pi. So I want you to think about what tangent is. Remember the ratio we said was that tangent was y over x. If I put the y over the x, root 2 over 2 divided by root 2 over 2, the tangent of 45 is a solid 1. All right. Now, if I go over here to this one, it's a -1. It's not the same. But look at this. If I go, this is 180 degrees or 2 pi around, pi around, just half a revolution. Y divided by x, negative root 2 over 2 divided by negative root 2 over 2, negative divided by a negative makes a positive 1. And that repeats. We get a positive 1 here, and then again, positive 1 up here, positive 1 here, positive 1 up there. Every half a revolution, it's going to repeat for your tangent. And it happens with all values of tangent, not just those. Okay? So tangent repeats itself every pi, so every half a revolution, whereas sine and cosine repeat themselves every 2 pi. And you might be saying, why is that important? Okay, well, it allows us to do lots of things, but one of them being, let's calculate some of these values in a easier way than having to just type it in a calculator. How could we get this without one? So it'll take a little bit of some manipulating to get it to look a certain way, but what I want to see is how else can I write this? Well, I could rewrite the stuff in the middle here, the 57,801 pi. I could write it instead as 57,800 pi over 2 plus 1 pi over 2. Right? They have the same denominator. 57,800 plus 1 is 57,801. So this is the exact same thing, but what I want you to think about is if I were to divide the 2 into that 57,800, let's do some division real quick. Again, the question does say without a calculator, so we can do this. 57,800, 2 goes into 5 twice, that 2 times 2 is 4, subtract that, 2 goes into 17 8 times, 8 times 2 is 16, subtract, 2 goes into 18 9 times evenly. So this, if I divide this right here, 2 into this 57,800, we get 28900 pi plus pi over 2. So here's where the magic happens on this question, guys. This is an even number of pi's, which means this value is representing full rotations around the circle. So that means, remember how every single full rotation, sine repeats itself? What I'm seeing here is an angle that is coterminal with pi over 2, right? This is the same thing as if I had pi over 2, but then from pi over 2, it went around the circle another 1,000 and something times, okay? But it's still going to land at pi over 2, which means that the sine of pi over 2 is going to be the same thing as sine of this whole thing. Essentially, if it's an even number of pi on sine, then I can get rid of that even number of pi. This guy, remember, because it's the period of sine is 2 pi, an even number of pi. And since that's the case, sine repeats itself every single even number of pi, I only need to focus on the pi over 2 part. And then if I had added this, it just would land in the exact same place. So sine would be the exact same thing. All right, so what I want to do is look at what is sine of pi over 2. And pi over 2 is the same thing as 90 degrees. I want you to look at your unit circle. It's hard to do opposite over hypotenuse from a 90-degree angle, but what we can do is look at the sine and cosine values from my unit circle. Remember how we've said that x is cosine and y is sine? At pi over 2, sine is 1. So my answer to this is just a 1. Let's try another one. Cosine. This one's a little bit weird, but it's okay. We can manage. I'm going to rewrite some of this. The number, you see how close these numbers are to each other? What I'm going to do is I'm going to rewrite this as cosine of 280.45 pi plus 8 pi. Yeah? Because this plus 8 pi gives me 288.45 pi. Let's subtract this other one, 280.45 pi. Now they're looking even more alike than they did before, right? Because they both have the 280.45 pi. This guy just has an extra 8 pi, but what I want you to remember is that is an even value of pi, which means this is talking about full rotations. It's actually 4 full rotations around the circle. So these angles are coterminal. This one, wherever it falls, it's just 4 more rotations than this other one, but they land in the exact same place. And so the period of cosine was 2 pi. That allows us to say that because this is even, it's divisible by that 2 pi, then it's going to land in the exact same place. And so that value is essentially unimportant, which I know sounds crazy, but you don't need it anymore because this is just a repetitive value. We're going to get rid of the 8 pi, just make it the 280.45 pi, and we're going to subtract over here cosine 280.45 pi. And because I'm subtracting a value from itself, my answer is simply 0. Crazy. All right, y'all, we got one more, and then we are done with 4.3. Let's look at tangent. Now, the period of tangent is different. Period of tangent is pi, so it could be odd or even. As long as it's whole values of pi, then tangent repeats itself, Okay, so you can think of it kind of coterminal, even if it's not. So in this situation, we have tangent pi over 4, but because this is a whole value of pi and that the period of tangent is pi, then every whole value of pi, tangent repeats itself, meaning I don't need this. It's kind of insignificant. Whether I had this value or not, my answer is the exact same because tangent would repeat itself. So here, I'm going to have tangent of just pi over 4. I don't need the whole values of pi that are extra. And tangent of pi over 4, we're just going to jump over to our unit circle. Pi over 4, tangent is y over x, root 2 over 2, divided by root 2 over 2, which is just 1. There's your answer. Crazy, right? We can do math like with these that it's just, if you get the hang of it, it's much quicker than going and reaching for a calculator and typing it in to get your answer. Okay? All right, guys, that is it for the rest of 4.3. Good luck, and I will see you in the next one. Bye.